Picture this. You look up into the sky and there it is, a bright reddish-orange dot, familiar yet different. This isn't the Mars we know today, cold and barren. This Mars is alive. Oceans of deep blue water lap against continents of lush green. White clouds drift lazily across the sky. Could this be our future? Could this be our second home? The answer might surprise you. We're closer than you might think to making this vision a reality. We're talking about terraforming Mars. Taking a planet that's currently pretty hostile to life and turning it into something, well, Earth-like. Sound crazy? It is. Crazy awesome, that is. Terraforming is like giving a whole planet a makeover, but instead of paint and furniture, we're talking atmosphere, temperature, and maybe even oceans. It's a massive undertaking, and Mars, our closest planetary neighbor, has emerged as the prime candidate for this ambitious project. Why Mars? Well, for starters, it's relatively close, at least compared to other planets in our solar system. More importantly, Mars has the potential for liquid water, a key ingredient for life as we know it. And where there's water, there's a chance. But let's not pack our bags for Mars just yet. While the idea of living on the red planet is incredibly exciting, it's important to understand the significant obstacles that lie ahead. The red planet presents some serious challenges that we must address before we can even think about colonization. First, the atmosphere is incredibly thin, about 1% the density of Earth's. This means that the air is not breathable for humans, and we would need to bring our own supply of oxygen or find a way to produce it on Mars. Think about trying to breathe on top of Mount Everest, but like 100 times thinner. Not ideal. This thin atmosphere also means that the planet cannot retain heat, leading to extreme temperature fluctuations. Second, the temperature is brutal. Mars is a cold desert, and the average temperature on the planet is a bone-chilling -62 degrees Celsius. That's -79.6 Fahrenheit. The coldest temperature ever recorded on Earth was -89.2 degrees Celsius, and Mars regularly experiences temperatures close to this extreme. That's colder than the coldest temperature ever recorded on Earth. And these temperatures can drop even further during the Martian night. Plus, Mars has a weak magnetic field, which means it's constantly bombarded by harmful radiation from the sun. This radiation can be deadly to humans and would require us to build habitats with significant shielding. These are just a few of the hurdles we need to overcome if we want to call Mars our second home. We also need to consider the psychological and physical effects of long-term space travel and living in a confined environment. But hey, challenges are just opportunities in disguise, right? With innovation, determination, and collaboration, we can find solutions to these problems and make the dream of living on Mars a reality. So how do we go about turning this cold, airless desert into a habitable paradise? The first phase of terraforming Mars involves cranking up the heat. Think of it like preheating an oven before baking a cake, except this oven is a whole planet. One idea is to use giant orbital mirrors to reflect sunlight onto the Martian surface, warming it up. Another option is to release super greenhouse gases into the atmosphere, trapping heat and raising the temperature. This warming process won't happen overnight. We're talking decades, maybe even centuries, to nudge Mars towards a more comfortable temperature. Once we've warmed things up a bit, it's time for phase 2. Creating a breathable atmosphere. This is where the real challenge begins, as we need to transform the Martian environment into something that can support human life. Right now, the Martian atmosphere is mostly carbon dioxide, which is great if you're a plant, but not so much for humans. The thin atmosphere also means that the air pressure is too low for liquid water to exist on the surface. We'll need to find ways to convert that carbon dioxide into oxygen, perhaps by introducing special types of algae or bacteria that can do the job for us. These microorganisms could be genetically engineered to thrive in the harsh Martian conditions and efficiently produce oxygen. Another option is to build giant atmospheric processors that essentially suck in carbon dioxide and pump out oxygen. These machines would need to be incredibly efficient and durable to operate in the Martian environment. Creating a breathable atmosphere is probably the most daunting challenge of terraforming Mars. It's not just about producing oxygen, we also need to increase the atmospheric pressure and temperature to make the planet more Earth-like. It will require groundbreaking technology and a whole lot of time, potentially thousands of years. This endeavor will demand international collaboration, continuous innovation, and unwavering determination. The dream of breathing life into Mars is a monumental task, but it's a vision that could one day become a reality. But imagine it. a Mars with a warm, breathable atmosphere. The final phase of terraforming would involve introducing life, starting with hardy microorganisms that can thrive in the newly hospitable environment. Over time, we could introduce more complex life forms, eventually creating a thriving ecosystem with plants, animals, and maybe even humans. This final phase is where things get really interesting, both scientifically and ethically. We're talking about engineering an entire biosphere from scratch. It raises questions about our responsibility to Mars and whether we have the right to alter another planet so drastically. The good news is that scientists are already hard at work, both on Earth and on Mars, conducting experiments and developing technologies that could make terraforming a reality. We have rovers exploring the Martian surface, analyzing the soil, and searching for signs of past or present life. Here on Earth, we're experimenting with different types of microorganisms that could potentially survive and thrive on Mars. We're also developing closed-loop life support systems that could one day sustain human colonies on the red planet. It's a long road ahead, but with each small step, we're getting closer to answering that big question. Could Mars be our second home? Of course, not everyone agrees that terraforming is the best approach. Some scientists argue that instead of transforming the entire planet, we should focus on building enclosed habitats or underground cities, creating smaller pockets of habitability on Mars. Others believe that instead of trying to adapt Mars to us, we should be focusing on adapting ourselves to Mars. This could involve genetic engineering or developing advanced technologies that allow humans to survive in the harsh Martian environment. These alternative approaches raise their own set of challenges and ethical dilemmas, but they highlight the ongoing debate about the best way to establish a human presence on Mars. So what do the experts say? Is terraforming Mars a realistic possibility or just a science fiction fantasy? The truth is, there's no easy answer. Some scientists believe that terraforming is entirely feasible, even if it takes centuries or even millennia. Others argue that the technological and ethical challenges are simply insurmountable. This debate is important because it forces us to confront fundamental questions about humanity's future in space. Do we have a moral obligation to preserve other planets in their natural state? Or do we have a right, even a responsibility, to spread life throughout the solar system and beyond? The journey to Mars, whether through terraforming or other means, will be the ultimate test of human ingenuity, perseverance, and perhaps even our ethics. This monumental endeavor will push the boundaries of science and technology, challenging us to innovate in ways we never thought possible. From developing sustainable habitats to creating life support systems, every step will be a leap into the unknown. It's a journey that will likely take centuries and require the collective effort of generations. Each generation will build upon the achievements of the previous one, passing the torch of exploration and discovery. The dream of a thriving Martian colony will be a testament to human resilience and our unyielding spirit of adventure. As we continue to explore Mars, we're not just searching for signs of life or even a second home. We're also seeking to unlock the secrets of the red planet, understanding its history, geology, and climate. These discoveries could provide crucial insights into the origins of life and the future of our own planet. We're searching for a deeper understanding of ourselves, our place in the universe, and the incredible potential that lies within us to shape our own destiny. The reflections and realizations that come from standing on another world will redefine our perspective on life, Earth, and the cosmos. So, will we one day walk beneath a Martian sky, breathing the air and feeling the warmth of a sun that shines on two worlds? Only time will tell. The vision of a future where humans thrive on Mars is both awe-inspiring and daunting, filled with challenges and opportunities that will test our limits. But one thing is certain, the quest to reach Mars is a journey worth taking. It represents the pinnacle of human ambition and the relentless pursuit of knowledge. As we set our sights on the red planet, we are reminded that the spirit of exploration is an intrinsic part of what makes us human. If you enjoyed this journey into our Martian future, don't forget to like this video and subscribe to our channel for more fascinating explorations. Hit the notification bell so you never miss an update. Together, let's keep the spirit of discovery alive.